So, you're preparing to take math at university. You may be facing large classes, fast-paced lectures, increased emphasis on understanding and not just memorizing rules, and you're also required to think more critically. At university, you'll be required to develop mathematical thinking and understanding. In Module Number 1, we focus on algebraic manipulations. We can use numbers like 1, 5, 7, 10 to count objects, such as the number of students in a first-year calculus course. But what about negative numbers? If students drop out, we show this as a negative number. If 20 students out of the 400 drop the course, 380 remain. The common notation for representing natural numbers is a double-struck n. If we're including negative numbers as well as positive and zero, these are called integers. The common notation for representing integers is a double-struck z. And of course, there are fractions or rational numbers. Any rational number is the ratio of two integers, m and n, where n is not zero. We need rational numbers to describe what happens when we split up a pizza. To calculate the share of pizza, we use rational numbers. A has 1/6, B has 2/6, which equals 1/3 of the whole pizza. C has 1/2 of the entire pizza. Rational numbers can also be written as decimals. 1/2 could be written as 0.5. 1/3 could be written as 0.3 bar. Notice these either have a terminating decimal like 0.5 or a repeating decimal like 0.3 bar. In the case of 1/3 written as a decimal, the bar above 3 denotes the repeating number. Some numbers cannot be represented as fractions. You should recall the Pythagorean theorem. In a right triangle, if the two shortest sides have a length of 1, the longer side equals the square root of 2. The decimal expansion of irrational numbers is non-terminating and non-repeating. It will appear as a series of numbers with no repeating pattern. We can represent all numbers on the number line with positive numbers to the right of 0 and negative numbers to the left. The number line includes all natural numbers no matter how large and negative integers no matter how small. Rational numbers can be shown on the number line. Irrational numbers can also be shown on the number line. The square root of 2 is a specific point on the number line. Note that root 2 is not 1.41 or 1.42, but these points are its close neighbors. By adding more decimals to our approximation, we get closer and closer to the location of root 2 on the number line. So, as a final recap, we have natural numbers, whole numbers, integers, rational numbers, and irrational. Taken all together, this gives us the set of real numbers. Now, we are ready to use numbers and the operations involved to simplify algebraic expressions. This is your first step towards success in university-level math.